We have a quadratic function here that is general in form, and when it's general in form, it's a little bit easier to find the intercepts, but it's a little bit more difficult to find the vertex. So we're going to go ahead and find the intercepts first, and remember that the y-intercept is found when we're setting x equal to 0. So f of 0 is going to give us negative 2 times the quantity 0 squared minus 4 times 0 plus 5. First two terms cancel out and we end up with 5. So my coordinates for my y-intercept are going to be 0, 5. Then the x-intercept is found by setting f of x equal to 0. So 0 equals negative 2x squared minus 4x plus 5. And the first thing I'm going to do is multiply everything by negative 1 so I can make that first term positive, and that makes it a little bit easier to see if we can factor or not. So multiplying both sides of the equation by negative 1 gives us 0 is equal to 2x squared plus 4x minus 5. This particular equation cannot be factored, so we have to go ahead and use the quadratic formula. And remember that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A is going to be equal to 2, b is going to be equal to 4, and c is going to be equal to negative 5. So plugging that in, I'm going to take the opposite of b, which will be negative 4, plus or minus the square root of 4 squared, minus 4 times a, which is 2, times c, which is negative 5, all over 2 times a, which is 2. Be careful when you go to multiply these second terms, you're going to be having a positive. So it becomes negative 4 plus or minus the square root of 16 and plus 4d all over 4. Simplifying farther, we end up with negative 4 plus or minus the square root of 56 all over 4. And 56 has a perfect square as a factor, and that's 4 times 14 over 4. Taking the square root of 4, I end up with negative 4 plus or minus the square root of 2 square root of 14 over 4. And now I want to simplify. And to simplify, I'm going to see what common factors do I have between negative 4, 2, and 4. And I have a common factor of 2. So I'm going to go ahead and factor out 2, and I'm left over with negative 2 plus or minus 1 square root of 14 all over 4. Then I can go ahead and cancel these factors of 2, and I'm left over with my x-intercepts are going to be negative 2 plus or minus the square root of 14 over 2. So remember that means that one x-intercept is going to be negative 2 plus the square root of 14 over 2, 0. And the other intercept is going to be negative 2 minus the square root of 14 over 2, 0. Next, we're going to go ahead and find our vertex. And to find our vertex, we're going to use the vertex formula. So the vertex formula is x equals negative b over 2a. So this gives me the x-coordinate of my vertex. Well, we found that b up here was 4, so I'm going to take negative 4 over 2 times a, which is 2. And that ends up giving me negative 4 over 4, which is negative 1. So negative 1 is the x-coordinate of my vertex. Now to find the y-coordinate, I'm going to take this and find out what the value of my function is when x is negative 1. And you can either use the function that we got when we multiplied everything by negative 1, or we could use our original function. I'm going to go ahead and use our original function, which gives me negative 2 times negative 1 quantity squared minus 4 times negative 1 plus 5. Remember to multiply negative 1 times negative 1 first, so we have negative 2 times a positive 1 plus 4 plus 5. And when we simplify this, we get 7. So the coordinates of our vertex are going to be negative 1, 7. Now I'm going to use all this information, my y-intercept, my x-intercepts, and my vertex, to graph. The last thing I'm going to want to remember is that the axis of symmetry is the equation of a vertical line, and it's in the form of x equal the x-coordinate of your vertex, -1. So now I'm going to go ahead and graph. My vertex is at -1, 7. Then I'm going to have a y-intercept of 0, 5. And then my x-intercepts, if I take -2 plus the square root of 14 and divide it by 2, I end up with 0.87. So my x-intercepts are 0.87, roughly 0. And the other x-intercept is -2.870. So trying to graph those two, we're going to be on the x-axis just a little bit shy of 1 and just a little bit shy of -3. I know from my axis of symmetry that it's a invisible vertical line going through my vertex. And I know that I have points on either side that are going to be symmetrical to that. So I have a point at 0, 5. I know now that I'm going to have one at -2, 5. And this is what my parabola looks like. I can then decide that since it's a parabola opening down, that this is a maximum. And I can also determine my domain and my range. My domain, if I take the entire function and I try to project it onto the x-axis, I'm going to continue going in the x and the y direction, so it's going to be -infinity to infinity. And then that was in the x direction. In the y direction, if I project it onto the y-axis, then I'm going to end up going from the negative to the positive, -infinity to 7, including 7. This is the example of a quadratic application problem. And we have an air freight company has determined that the cost in dollars of delivering X parcels per flight is C of X equal to 2,025 plus 7X. And the price per parcel in dollars the company charges to send X parcels is given by this. Okay, the first thing it says is to find the revenue function. And to find our revenue function, that's going to be our price per parcel times the number of parcels, which is X. So the number of parcels, X, times the price per parcel, 22 minus 0.01X. So this is X times P of X. And then simplifying that gives me 22X minus 0.01X squared. So that's my revenue. To determine my profit function, that's going to be my revenue minus my cost. My revenue I just found out, 22x minus 0.01x squared, minus my cost, which is this one right up here. Make sure you use parentheses when you put down your cost function, because you're going to be subtracting this quantity. So when you go to subtract it, you need to make sure that you carry through the subtraction sign. So it becomes minus 2025 minus 7x. Simplifying gives you P of X equals negative 0.01x squared plus 15x minus 2025. So this is step 1, or A. This was B. C says to determine the company's maximum profit and the price per parcel. So the maximum profit is going to be obtained when we get to our vertex, and since we have a parabola opening down, our vertex is going to be that maximum value at whatever the price per parcel is. So we're going to go ahead and use our vertex formula, and we know that x is equal to negative b over 2a, negative 15 over 2 times negative 0.01. So that gives me 750. So that means that when I sell 750 parcels, we'll be at our maximum, but that doesn't tell me what the maximum profit is going to be. So I need to put in x equal to 750 into this function, and that'll tell me what my maximum profit is. So P of 750 is equal to negative 0.01, 750 squared, plus 15 times 750, minus 2025. So calculating this out gives me 3,600. So that means that when I produce 750 parcels, I will have a maximum profit of 3,600. So that's maximum profit is $3,600. And then it asks me in that same question, the price per parcel. Well, we have 750 parcels. The price per parcel is given by my price per parcel equation. So little p of 750 is equal to 22 minus 0.01 times 750, which ends up giving me $14.50 per parcel. And then it says, determine the minimum number of parcels the company must ship to break even. So on this particular problem now, we want our profit to be 0. So that's the part D. Where is my profit going to be equal to 0? Where am I going to break even? So I'm going to take my profit function, which is right here, and I'm going to set it equal to 0. And then we can either use our calculators or we can use the quadratic formula. I'm going to go ahead and use the quadratic formula. So I have x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b, which is negative 15, plus or minus the square root of b squared, 15 squared, minus 4 times a negative 0.01 times a negative 2025 all over 2 times negative 0.01. Simplifying, this gives me the square root of 144 over negative 0.02. So I either have negative 15 plus 12 over negative 0.02, or I have negative 15 minus 12 over negative 0.02. So that's going to give me two different values for x. The equation simplifies to 150, and the second one simplifies to 1,350. So that means that if I sell between 150 and 1,350 parcels, I'll be making a profit. Anything below those values, I'll be doing a loss, and right at those values is where I'm going to be at 0 profit.